communications will be tracked and the dialogues will be saved. That will be done at the SEM layer. So it keeps track of all sessions and dialogues. Then from there, the data will now be transported to the transport layer. At the transport layer, there are 6 various functions that will happen at this data as it arrives at the transport layer. First, when the data arrive at the transport layer, the transport layer will have to identify what protocol is used in this data, whether it's a HTTP protocol, whether it's a TCP protocol, or what type of protocol. It doesn't matter. It will have to find a way to know what protocol. How does it find this? Is the port number. So each application has a port number, and the transport layer will identify the port number. That is one function. Second function, it will segment the data. That means it's going to cut the data into smaller pieces, so those pieces will be transferred and each piece will be given an identification number. So all these pieces will be able to transport equally within different mediums, and then they will arrive at the destination without any problems. In doing so, they must also be able to multiplex. So we have identify port number, segmentation, and multiplexing plus demultiplex. Multiplexing and demultiplex. Multiplexing is done at the source end, and demultiplexing is done at the destination end. Then from there, the fourth one is sequencing and reassembly, because the data will be cut into segments and each segment will be given a sequence number. Let's say, for instance, hello, how are you? 1 2 3 4. Hello, how are you? So that means each of these species that I've just said right now will have an identifier, will have a sequence number. So if I send a data to my destination, I will have to wait until he receives everything and reassemble. Maybe my you would come first before the hello. So in that case, it will have to wait until everything arrives, and then it will rearrange it in the ascending order. Then from there, the fifth function of the transport layer is the flow control, and the sixth is error control. So the flow control is that it makes sure that the data that leave from source is the same data that arrive at the destination. Then the error control makes sure that that data that is sent between the source and the destination is error free. So all these 6 functions operate or happens at the transport layer. So at the transport layer, we have 2 protocols, that is TCP and UDP. And at this layer, the protocol dependent unit that operate here is called the segment. So we have data, we have segment. Then the next one is network layer. At the network layer, what happened is that these segments will be encapsulated into an IP packet, and then so that they can be transported. So in that case, the segments will be turned into packet, and the protocols that are responsible for carrying those packets are IP protocols. Routed protocols and routing. So some examples of those protocols are IP version 4, IP version 6, ICMP version 1, and ICMP version 6. So you have Apple Talk and IPX are all examples, but they are outdated. They're not used now. Now from there, the packets will be sent to the data link layer, and that data link layer will now add a data link information, that is the layer 3 information, or you call it the MAC address information, to the data. So from there, this data link layer will turn these packets into frames, because it's what it can understand. So those frames will be responsible for forwarding those data into the cable or into the physical layer. At the physical layer, then those frames will now turn into bits. So so those bits are what will be transmitted across the media. So that is what this OSI model does, from the application layer down to the physical layer. When you send an email, so when you are receiving an email, the reverse occurs from physical data, network, transport, session, presentation, and then application. So this is basically what happened, guys, and then I hope you guys understand this thing. So each of these layers, the OSI layer is divided into 2 parts. We have the upper layers and we have the lower layers. So the upper layers of the OSI model are application, presentation, and session layer, 3 layers, and transport, network, data link, and physical layer are called the bottom layers. So we have top and bottom. So that's what I explained, and then you guys can also read and make sure that you take some notes as I'm explaining, or as I was explaining. Take note, and all these functions you jot them down. So like I said, the application layer will contain protocols that are used for process-to-process communication. So you can be asked in an exam which of the following layers of the OSI model is responsible for process-to-process communication. In that case, it's talking about application layer. And the presentation layer provides for common representation of the data. The system provides services to the presentation layer to organize dialogue and to manage data exchange. The transport layer defines service to segment, transfer, and assemble the data. The network layer provides service to exchange the individual pieces of data over the internet or over the network between identified end devices. So even you might be asked in an exam any of these things, so you just have to be ready to answer the questions from this explanation. So the TCP/IP model is created in the early 1970s when I was not born, and it's here I am talking about it, guys. So you guys will also have to read. So the TCP/IP model is only divided into 4 layers, and I explained that one before. So the OSI model, the network access layer, and the application layer of the TCP model are further divided to describe the discrete functions that must occur at these layers. So that's why they are combined together. Alright guys, so we talk about some of the things here that are very important, but there is something that I would like you guys to take note of. We have the protocol dependent unit. The protocol dependent unit has only one specific function, that is to say it makes sure the data move between sending and receiving device. That's what this protocol dependent unit is. It guides and controls. It describes in a way that this data. So the protocol dependent model in ascending order or descending is, we have the data, segment, packet, frame, and bit. So you may be asked in an exam to arrange this properly. So the proper format of arranging the PDU is data 1, 2, segment, packet, frame, and bit. Please take note of these things, guys, and make sure that you read. So the large stream of data are divided into smaller or manageable pieces to send over the network, and this is referred to as segments. So by sending those smaller pieces, many different conversations can, let's say for instance, in the same network or on my same device, I can be sending email, watching YouTube, playing video game. I can do a lot of different things at the same time on my computer. So therefore, all this will go in as smaller pieces. So in order for them not to collide, it needs to be multiplexed so they can interleave, so that you can have different communications to interleave within the same area and they will not have any problem. So each piece must be level, and if part of the message fails to make it to the destination, only the missing piece needs to be retransmitted, and all that retransmission is done at the transport layer. Okay guys, so like I said, that is the PDU. As application data is passed down the protocol stack, information is added at each level. This is known as the encapsulation process. So the form that the data takes at each layer is known as the protocol data unit, or before you can call protocol dependent unit. So it's called data unit, okay, PDU, and that's how the PDU is arranged. So guys, the encapsulation process works from top to bottom. You can also work from bottom to top, no problem. So that's how data moves. So network addresses, so network layer source and destination address are responsible for delivering the IP packet from original source to the final destination. So IP address is very important because it provides the end-to-end connectivity. So data link address is the MAC address, or you can call it layer 2 address, or you can call it the physical address. We'll have to know all the names that are given to all these addresses later on. So the purpose of the data link address is to deliver the data link frame from one network interface to another, but that is done within a local area network. But if the data has to move, or the packet needs to move out of the local area network, it will need the IP layer 3 information. So a device on the same network would have the network layer address or IP address indicate the original source and final destination. So therefore, in every IP address, we have the source and this, we have the network person and the host person. So IP address is divided into 2 portions. We have the network and the host person, both IP person 4 and IP person 6. So the data link frame, which uses MAC addressing, is sent directly to the receiving device. So that also, devices in a network must have 2 addresses, that is the MAC address and IP address. So we are running against time, so therefore I may not explain. So each of these things also have their own chapters that we will discuss them. So sending to a remote network, the source and destination IP address represent hosts on different networks. So therefore the data link frame cannot be sent directly to the remote destination. Therefore it will need a router, a default gateway that will forward these packets, and that has to be a layer 3 functionality. So we'll explain all of these things. So guys, that is the end of the chapter, and like I said, you're welcome to the tea time. Make sure that if you have any questions, you ask me directly, or you can write to my YouTube channel, or you can write to the WhatsApp group. And guys, I hope you guys did some practicals, like with the practical scenarios I gave you before. I see you guys in my next video. Bye bye.